Good afternoon, at least for me. Good morning, good evening. So welcome to this session, one of a series of presentation about 3 call for technologies and 5 standards that the Empire General Assembly has decided to publish at the last General Assembly. 2 words about MPAI. MPAI stands for Moving Picture Audio and Data Coding by Artificial Intelligence. It is an international, unaffiliated, not-for-profit standard developing organization. It develops AI-based data coding standards, but it tries to add also clear intellectual property rights licensing frameworks. This is our organization. It may look very complicated, but what matters is here, development committees. These are the groups that develop standards, like the one that we are presenting today, the Multimodal Conversation. And then we have another set of groups that develops or are preparing the development of new standards. So this is a presentation, not of a final standard, but one step before. In order to explain better, let me say how we do develop a standard. So imagine that someone comes in and say, I think that this would be a great standard. Then before saying, yes, you're right, we study use cases where this proposal can be applied. We try to derive functional requirements from these use cases and commercial requirements. The package of these 2 documents is attached to what we call for technologies, whereby we can obtain the necessary technology to develop the standard. And when the standard is, we believe, done, we publish it for community comment. So here is where we are, the last stage before going to technical specification and publication. So MPAI is about data coding for based on artificial intelligence. And our standards are designed to provide a better AI for end users, but also for the industry. So what we try to do is to make explicit the computing workflow of AI applications. By means of that, we think that humans can select applications whose internal operation they can somehow understand, and that is important, because today, if you use an AI application, most likely you don't have the least idea of what is happening inside. So we break up the monolithic application into a set of interactive components that exchange semantics of known data. Of course, the semantic is known to the extent that it is possible to know it, but at least this is the intention. Then, based on this, developers can compete by offering standard components that they can claim and they can prove to have a better performance than those of their competitors. So the summary is our standards are component-based, and an AI application is subdivided into smaller components we call AI modules. They are aggregated in one or more workflow, that is the application use case, and executed in a standard environment that we call AIF. All this is specified in one standard that we have developed, I would say, close to 1 year ago, 2 years ago. So this is maybe it's a little bit daunting, but I'm not going to explain it. And so the AI framework, here you see that we have the individual component. They are somehow interconnected. They are controlled by this control. They can access APIs for security services. This was the one foundational standard. We have a second one that is also very important. Every standard creates an ecosystem where you have, well, the entity developing the standard, then we have the developers, you have the integrators, you have the consumers. Now, we wanted to add, and we actually have already added to the MPI ecosystem, a new entity that is called the MPI Store. And this MPI Store guarantees that the components that are used to create applications or the applications themselves are interoperable, trusted, and available. All this is specified in the system technical specification governance of the MPI ecosystem. Let's see what the MPI ecosystem is. Here we have MPAI, issues standards, appoints a performance assessor, establishes the MPI Store, which we have done. So here you see, so MPI has produced a standard. Here you have an implementer, develops an implementation, submits the implementation to performance assessor that says, okay, this implementation has a certain level of performance. Then we have the MPI Store I've talked about. What's the goal? To verify the security of an implementation, to test the conformance of the implementation with the standard, and to check the performance. I'm saying not a test, but checks in the sense that it simply receives the result of a performance assessment. Finally, you have an implementer that submits an implementation to the MPI Store. And if everything goes well, then the implementation is posted on the MPI Store so that an end user can download and use and communicate back to the MPI Store their experience score. More standards. So we used to have 4 technical specifications on audio, on financial data, on multimodal conversation, and neural network watermarking. Earlier this year, we developed and posted 2 technical reports on the MPI metaverse model. But last month, we have published 5 standards for community comments. We plan to make them standards on the 29th of September. Can you please mute? So here we have existing AI MPI standards that have been extended. We have the AI framework, the one that I have introduced at the beginning, multimodal conversation, which is what we are going to talk about today. And then we have new standards that are being approved, the avatar representation animation, connected autonomous vehicles architecture, and MPI metaverse model architecture. There are also more things that are brewing. We have 3 calls for technology that have been issued: artificial intelligence for health, object scene description, and extended reality venues, live theatrical stage performance. I would love to talk about this, but unfortunately, this is not the time. And we have more activities on video coding, on online gaming that we are considering. Finally, MPI does not live in isolation. IEEE has adopted, without modification, 4 standards, and the 5th is on this way. And all this, I'm proud to say, has been achieved in less than 3 years. So this was the introduction. Let me go to the presentation of the multimodal conversation. This will be done in two phases. First, I will introduce some general things, and then we will have Mark, who will go in details in particularly important aspects of the second version of the multimodal conversation standard. So, multimodal conversation, what's the goal of this standard? We wanted to provide the technologies that enable a human-machine conversation that is more human-like and able to emulate human-to-human conversation in completeness and intensity. So we wanted to improve the machine's conversational capabilities in the two main phases of the conversation. First, you understand what the other guy is saying, and then you generate a pertinent response. Now, of course, this is related to the machine a human is talking to. The version 2 of multimodal conversation achieved these goals by introducing, there are other things, but in the interest of time, we will be talking only about this one. It's a new data type. It is called personal status. Personal status represents the internal status of a human that is conversing with a machine. I mean, the same, of course, applies to humans, but here we are talking about machines. So this internal status is expressed, is conveyed by text, speech, face, and gesture. So the personal status can be used by the machine to represent its own internal status. So in order to have an effective human-machine conversation, the human has, because we have, an internal status, and we will say more about this. The machine tries to mimic its own personal status in order to be more effective in the conversation. So what is the scope of this standard? It is technology for analyzing text, speech, and other non-verbal components used in a human-machine and machine-to-machine conversation. We also specify the functions and the formats of the input and output data of the components that we are talking about. And we also define the use cases that are then implemented as AI workflows. And currently, this is the list: conversation with personal status, conversation with emotion. This is an early version that is kind of superseded by conversation with personal status. Then we have multimodal question answering, conversation about a scene, interaction between a human and a connected autonomous vehicle, virtual secretary for video conference, and speech translation. We have three of them that, I mean, they are not in version 2. They were already developed in version 1. So let me go into some specifics. So this we have selected this use case because it is kind of representative of the many things that you can do by adding, removing components for different applications. So here you have a conversation with the personal status. So here you see we have the front end. The front end, we have a visual scene description. So it analyzes the visual scenes. There is a human speaking. They are objects. And therefore, the machine creates a map of what is there. We call the map the visual scene geometry. And you know, because human are particularly important, we want to extract in-depth descriptors of the body and also in-depth descriptors of the face. Because, of course, analysis of these two are important components in this multimodal conversation this standard is about. Then we have a second front end, that is the all you're seeing. This is simpler in the sense that we just extract the speech, and then let me follow this line. So we have the input speech, the speech is recognized, and we get the recognized text. Then this is provided to language understanding, and the purpose of language understanding is to refine the text and to provide the meaning of the senses that has been uttered by the human. Meaning and text are provided by supplied to dialogue processing, and the dialogue processing provides the answer to the utterance of the human. So this is, say, the traditional way of representing human-machine interaction. But here we are in the multimodal business. Therefore, we wanted to introduce this new entities, which is personal status. Personal status is the representation of the internal status of the human. Of course, it is not the real internal status. I mean, we humans are very good at hiding our own sentiments, our own internal attitude. But, you know, by using body descriptors, face descriptors, speech, and meaning, this machine is capable to capture a good estimation of the input personal status. Input in the sense that this is what goes into the dialogue processing together with meaning and text. Then the dialogue processing this time not only outputs the text, but also its own personal status. These two entities are passed to the personal status display, which produces machine avatar, machine speech, and machine text. So the machine is represented as an avatar. It can be, say, just the head. It can be half of the body, or it can be full body. This is the synthetic speech. And this is, in cases it is needed, the machine text as well. So this is was quite a long explanation, but you know, this is really at the basis of what this standard is about. And of course, we are providing the technologies to implement this reference model. So what is the standard about? The standard says what the use case does, the reference diagram of the use case. Then it says which are the input and the output data coming into the system. Then it says, okay, we have these AI modules. What do these AI modules do? Well, we have a list. So these are the AI modules. And here is the function of each of the AI modules. Finally, this is, of course, the most important part is which data types are exchanged between one AI module and another AI module. There's not at the end, because we have JSON metadata as well, because, okay, we have an AIF. AIF has certain capabilities that are described with JSON metadata. Then we also needed to have the description of the capabilities of the workflow. And we also needed the description of the capabilities of each of the AI modules. In this way, we can achieve a match between the processing capabilities and the complexity of the workflow that we wanted to execute. So here we have another use case. And this time I will be much quicker, just to show you that besides the fact that here we are talking about a car, so a car has an inside where humans stay, but they also have an outside. And the outside is when, for instance, humans comes in and tells the car, take me home. And of course, we need a speaker recognition, we need face recognition, but you know, then the dialogue. Because we have envisioned that the human in the cabin and the connected autonomous vehicle can have a conversation, and therefore we have more or less the same things. But this is just a module, a subsystem that is dedicated to interaction between the car and the human. But we have more things here. For instance, we have the autonomous motion subsystem that is capable of, say, designing the route between here and the destination, and can also do, of course, a lot of other things. But the end point is that here we have, again, the personal status display, which is capable of representing the car as an avatar. More interesting, maybe, is the virtual secretary for video conference. So we have another big use case where we have a human participant joining a virtual video conference where their voice is their actual voice, but their figures are represented by avatars. The avatars, say, are sitting around the table. So now we have a virtual secretary whose goal is to create a summary. This is the goal of the virtual secretary. So what does this guy do? Of course, this is not a human. So first of all, it has the usual speech recognition, language understanding, dialogue processing as usual, but it has also, say, the visual front end. And now, the visual front end is different from the one that we have studied so far, because here the avatar is already, each participant is represented by an avatar. Therefore, the only thing that it has to do is to extract from the avatar the body descriptor and the face descriptor so that it can activate the personal status extraction. And this is additional information that is added to the summarization process because, and Mark is the originator of this. This is an excellent idea. It not necessarily this sentence means that it is an excellent idea. And so the virtual secretary has to dig for more information in the personal status. So this is, we are going now more in depth in something that Mark will give more details of. So this is how do we extract the personal state? Okay, we have two phases. First, we describe the information, and then we interpret the information, and we get the personal status of text, speech, face, and gesture, and all this is combined into one data format. Another component is the one that I have presented before, the spatial object identification. This is not specifically designed by this group, but it's part of the standard. Finally, we have the personal status display. So this one. So what is the purpose of this? We have text. And we have personal status as a speech, as face, and as a gesture. So all this is, so text and personal status of speech is used to synthesize speech. The text and the personal status of face, based on a given avatar model, is used to compute the face descriptors, and we have again the text, the avatar model, and the personal status of gesture that is added to both the description to create a gesture description. This avatar description is an AI module that combines the descriptors of face and description of the body, of gesture, and the output can just be descriptors. So like we have used in the virtual secretary for video conference, or it can be the synthesized avatar that is ready for rendering. So this is probably my last slide, and we have here the full list of the data types that we are standardizing. So face descriptor is not standardized by this multimodal conversation, but it's used by the multimodal conversation. The name of the standard is avatar representation animation, same for descriptors. Then we have meaning. Meaning was already defined in version 1. And then we have a personal status. And it is because of that, this is a good time to pass the ball. I don't know if this is the English expression. To Mark.
You can pass the baton, Leonardo.
The baton. Okay, so it's a French. Is the French?
That's
baton.
right. I will be the anchor runner here.
Very good.
So
please.
I'm going to share my screen with you now.
Absolutely.
Release the screen.
Yeah.
But I will. Just a moment. I will indeed share my screen. And the one I want to show you is this one here. So. I trust you can see it, Leonardo, and you too, Sylvie?
I do.
Okay, Sylvie, you're still with us? Hello, Sylvie. We want to make sure you're
Yes, I
still
am.
with
I just had been cutting my audio. Yeah, I
us.
hear you.
Okay. Okay, so what is this thing that we call personal status? You've heard the term several times. It's a set of standard terms for describing people's emotions and their cognitive states and their attitudes. So why do we need to standardize terminology in this area? As you've been hearing, if computers are expected to converse naturally with people, they need to recognize what people are feeling, what people are experiencing, what attitudes they're presenting. And on the other side, if computers are expected to behave naturally with people, then they need to simulate those feelings and those experiences and those attitudes. That is, assuming that they don't actually experience those feelings, they're simulating. Whether they can actually experience those feelings is another story, which is not for today. So you can ask, is it possible to compile a perfect set of standard labels and descriptions for this sort of personal status? And the answer will be no, it's not possible. Emotions, cognitive states, attitudes, all of these are intrinsically fuzzy and vague and overlapping. But some kind of working set is necessary. So we give it our best current attempt, our best current shot, while we are fully recognizing that it's not perfect. We're recognizing the imperfection of the current set of labels and descriptions, and we do have procedures in place for revising or substituting the current listings. So with that, let's get down to brass tacks, as we say in English, down to details. Personal status is a data structure that has three personal factors. One is the emotion, like angry or sad. Another is the cognitive state, like surprised or interested. And the other is a social attitude, like polite or arrogant. And all of these factors can be expressed through modalities, presently either text or speech or face or gestures. In the future, we might have added body posture. But within a given modality like speech, the factors are analyzed and interpreted through descriptors, as Leonardo began to say. For example, when you're using speech as a modality, the elements can be expressed through prosody, that is the movement of pitch or rhythm or volume, and through separable speech effects like vocal tension or breathiness, and through vocal gestures like laughs or sobs. Now there are two tables, and I'm going to show you examples for each of these, for emotion, and two more for cognitive state, and two more for social attitude. And the first table in each of these sets is just a listing of all the labels that we use. But we do them in a format that has three different levels. You're going to see on the left that there is a category. So if we're talking about emotions, category might be anger. We use nouns to express the category. And then we have adjectives that are the labels themselves that for the emotions in this case. So angry would be a typical label. That's a general description of anger, but there can be more specific ones like furious, which would mean something like extremely angry. But in addition to having the listing of the labels themselves, we want to have explanations of the meaning, the semantics of each label. So we have a second table that presents those semantics. And for example, you'll see that angry as a label is glossed or described as emotion due to perception of physical or emotional damage or a threat. And we've done our best to supply these, although it's always going to be a tricky job. Now, Leonardo was telling you that we use the JSON format for the technical description of all of these. And so let's look, for instance, at the first element of that JSON, which would be a timestamp. You can have an emotion that changes in time. So at first you can be sad, but something happens to make you happier. So we want to be able to indicate the timestamp, and that can be done either from the beginning of an episode, a session, or in a more standard way. We can also have descriptions of emotions, cognitive states, and social attitudes, and those break down as follows. If you look at the emotion here, I think you can see my cursor move. Then you would see a mention of the emotion version. As I said, since we expect revisions of all of these label sets, we want to know which label set we're using now for emotions. Let's skip over fused for a moment, but look at the emotion as expressed through text, through speech, through face, and through gesture. And once we've evaluated all of those, we might want to put them all together to get a single description of emotion that was gathered from all four of those modalities. That would be the fused emotion value. And you have a similar format for the cognitive state and the social attitudes. Here, we're going to start looking at the tables that I told you to expect. And I think it's illustrative to look at this interest line here as one sort of cognitive state, one category of cognitive state. The adjective that goes with the category of interest is, of course, interested. And there can be several subcategories. So fascinated is a subcategory of interest, curious, and bored. Well, let's go to the next slide, in which we have descriptions of all of these. So that if you look at line 13 here, interested is described, as best we can manage it, as the cognitive state of attentiveness due to salience or appeal to emotions or drives. That's the general level label, interested. But if we want to look at the subcategories of interest, we have line 12, fascinated, which is, we gloss as high degree of interest. And in line number 9 here, curious is shown as interest due to drive to know or understand. And finally, bored in line 5 here is simply not interested. So this gives you some idea of how we approach the cognitive states in terms of their label sets, and also the descriptions of their semantics. In a very similar way, we approach emotion label sets. In this way, let's look at the fear general category, in which case the adjectives would be fearful, scared, or frightened, which didn't appear here. The subcategories there would be terrified, which is obviously going to mean something like very scared, and anxious and uneasy. But to be specific, let's look at their lines in the semantics tables. Line 13 here is describing fearful or scared as an emotion due to anticipation of physical or emotional pain or other undesired event or events. And we can also see uneasy. Let's see, anxious and uneasy described here as a low or medium degree of fear, often continuing rather than instant. I don't think that the one for terrified appears on this slide. We didn't have room, but you can imagine that it will be a high degree of fearfulness. And finally, we're looking at the social attitudes, and there are many. Last time around, I think we got more than 100 different labels as we collected these. Let's look at the aggression line here, or category. labels within this category are aggressive, peaceful, or submissive at a general level, but at a more specific level, combative, belligerent, passive-aggressive, or mocking. And if we look at the definitions, then aggressive on line 3 is described as tending to physically or metaphorically attack, whereas we have on line 16 we have combative or belligerent as glossed as high degree of aggression, often physical, and so it goes. This is the flavor of our label sets and their descriptions. What happens now is that you, Sylvie, and others are invited to comment on the general format, on the general approach, but also on the specifics of the labels. And those comments ought to reach us if you want to affect our first presentation, first publication. They ought to reach us by the 25th of this month in any format that you like. And the standard will be published at the end of the month. What are we going to do with all of this? Not only the personal status material, but everything that is in the multimodal conversation section. We will have reference software, that is sample working software for all use cases. We will have specific procedures for testing that the modules that are presented to us conform to our standards. And we will have a way of assessing the performance of all of those modules for the purposes of the store, people who want to acquire those modules. We'll also, as a parting shot, we want to explore the relationship of large language models like ChatGPT with the component-based approach that we're suggesting. So it will be important to take this forefront conversational AI and find out how it can interact with our modules. I think it's back to you, Leonardo, to
But you can